there's a rough inclined plane. I kept a block and I'll put a condition that tan theta greater than mu s. So if I don't apply this horizontal force, the block will slide. So find the minimum and maximum value of f for which the block will be at rest on an incline. So there's just an inclined plane on an inclined plane. Now what is the tan theta? Tan theta I made greater than mu s. So directly again get into the forces here. So there's a normal contact mg cos theta, mg cos theta. Here this will be mg sin theta. What action the friction should act here? As the friction will act up the incline. I'm going to apply a minimum force. I think I'll draw the other diagram. Huh? Because let this be question as it is. You'll get confused because two cases we are discussing. No? I'll take the other diagram here. The horizontal force. Let's go for free body diagram. The normal reaction or the normal contact in mg cos theta. Now what is the direction of friction? The frictional plane, I applied a minimum force, the friction will be acting in the direction. Is it a limiting? Yes, it's a limiting friction. FL, you write it. Now we will resolve this F, the applied force will resolve it.
Sir, for minimum force, will it be limiting, sir?
Oh, yes, you do make observation. So let me resolve this. So this angle will be theta. If apply force less than F minimum, what is the minimum value of force? What happen? You can apply it. Maximum force and minimum force. If apply force less than F, the block will slide down. If apply force greater than F max, the block will slide up. So that's why the minimum maximum are coming. So here I'm directly writing this F minimum. I'll resolve this F minimum along the incline. So what are the components? F minimum cos theta. So we will balance along the incline. Along the incline. F minimum cos theta plus FL minus mg sin theta equal to 0. Then perpendicular to incline or normal to incline, you write it. Normal to incline n minus mg cos theta minus F minimum sin theta equal to 0. And we know what is friction will be mu s n. Okay, let's substitute this value. FL equal to mu s n in the above. These are the basic equations I brought you. What is FL? Mu s n.
Sir, okay.
Sorry, it is about to shift. We are discussing. No, about to shift. The block is about to shift.
Okay, sir.
What is n? N should be equal to mg cos theta mg sin theta equal to 0. Solving this, F minimum okay, the value of n is equal to, so here, how do this equation came? F sine theta will act along mg cos theta, no? So therefore, n is equal to, so if I resolve it, this will be F minimum sine theta. Here, if I resolve it, F minimum cos theta. So therefore, the n is equal to how much? F minimum sine theta plus mg cos theta. So this equation will be F minimum cos theta plus mu s sine theta. They should be equal to mg sine theta minus mu mg cos theta. F minimum equal to mg sine theta minus mu s cos theta all divided by cos theta plus mu s sine theta. Take this common. Let me take cos theta common. So this will be tan theta minus mu s by 1 plus mu s tan theta. Rather than numerical, do remember this. Almost in 7 chapters, this idea is going to come. Not 1, 2, in 7 chapters. This one. Okay, got this. So why I should call the minimum word? If I apply force less than F minimum, the block will slide down. That's why I brought the word F minimum, that one. So anyway, tan theta greater than mu s, no, the condition. So this is the F minimum, that one. So why do the word maximum came again? Look at this. It's asking minimum, maximum, no? I'll keep on increase this applied force. I'll keep on increase this applied force. The value of F, I'll keep on increase. Then at one specific value, so depend the friction will be 0. And as I further increase the value of F, the friction will change the direction. It will be static. Then as I keep on increase further the value, what happens? The friction will become limiting. So when I apply the maximum force, how the friction will be acting? The friction will be acting down the incline. Just do make observation. This is what we brought it here. So this is the one, the first case. This is the minimum value of force what I should apply to keep the block in place. If applied force less than F minimum, what happened to block? Block will slide down. And let's go for maximum situation. For maximum case, what is the condition, like how we have to assume? So here is the block, this is inclined plane. Kinematics very easy because it's all about the mathematics, but here the real physics has entered. So most of you find very difficult. It's quite natural because here not just mere mathematics, the clean observation of the situation first you have to understand. Then only you can manage things here. See, math-based questions will be there, but how many? Very less. We need mathematics to end up the answer, but to understand concept of just mere mathematics will not help us. The observation, nothing is there. Don't call concept here. In the physics outline, we don't have any weightage for the word concept. What we have weightage is the observation. The more observation you should make. Now I applied a maximum force. This also you can try at your home. Take notebook and keep, or take the pad, writing pad, keep eraser, take pencil or pen, try to push it horizontally, the force. Try to increase force, decrease force, apply force. So now I applied a maximum force. What is the block is at the verge of sliding up. Then now the friction should act down the incline. Then the mg sine theta will be like this. So if I apply force just greater than F max, the block is going to slide up. So therefore here the limiting friction should be there. So again you resolve the forces that are acting. This will be will break up this force. This will be F max cos theta. And this will be F max sine theta. Okay, fine. So let's write the equation. First along perpendicular to incline, normal to incline. N minus mg cos theta plus F max sine theta equal to 0. Then along the incline, F max sine theta minus mg sine theta minus FL equal to 0. What is FL? FL is equal to mu s n. So substituting this, F max sine theta mg sine theta mu s n. Rest all everything calculations. So we'll substitute the value of n from the above equation. That should be equal to mg cos theta minus F max sine theta equal to 0. And this will be negative. What is F max? F max.
Sir, along incline F max cos theta.
What I wrote? Oh, here. Okay. Thank you for correction, ma. F max cos theta. Okay, just check the thing, that one. So perpendicular normal to incline n minus mg cos theta minus fx sine theta. Along the incline f max cos theta mg sine theta minus fl. The directions here, fl mg sine theta f max cos theta. So solving this, f max cos theta minus mu s sine theta equal to mg sine theta plus mu s mg cos theta. This should be sine theta
Sir, will this once show F minimum, sir?
Wait. Let me finish off this part. Okay, fine.
Yes, sir. Thank you, sir.
I don't know something. The slider is not working. Okay, come for this. This will be mg sine theta plus mu s cos theta. In the denominator, it will be cos theta minus mu s sine theta. So what is the resultant expression will be? I'll take cos theta common. Tan theta plus mu s by 1 minus mu s tan theta. So definitely you can see there's a difference there, no? So now, what is the value of F for which the friction will be 0? Because you see, okay, for the friction for when you apply minimum force, it was acting up the incline. When you apply maximum force, the friction was acting down the incline. So is there any value of F for which the friction will be 0? Already, I think I discussed, recollect once. I'll have water. Anybody? Is there any value of F for which the friction will be 0?
Sir, F equal to mg sin theta.
Mg tan theta.
mg sin theta, sir.
Mg tan theta.
F cos theta equal to mg.
F cos
Yes, sir,
theta
yes,
equal
sir.
to F cos theta equal to mg sin theta. So if I apply force, F equal to mg tan theta, the friction will be 0. So definitely there's a very beautiful information is hidden here. What is that? F less than, I'm concluding everything, F less than F minimum. So what will happen to block? Slides down. F greater than F max. Block slides up. The value of F between less than F max greater than F minimum. Block will be at rest or in equilibrium on the incline. Then when F is equal to specifically one value mg tan theta, the friction will be 0. No friction will act, though it is rough. So now I'm going to, so when you look at the more than one option, especially in SU or Mano, very dangerous questions they are. Because somewhere in the numerical, some idea what happened is made as a question. No, if block is kept on rough surface and an external force is acting, still friction will be 0. Yes, this condition is possible, no? The last thing, I'll give the diagram also. So this is what happens when you're dealing with SC Verma multiple options questions. So students just they read and they remember. But every what happen for every question what happen, you can really there is some problem hidden in that. I applied a force, so how much equal to mg tan theta? No friction. Friction will be 0 here. No friction, and though it's a rough, I'll write mu s. Then no friction acts on the block. Tell me like that particular option, just you have to remember. So many students, they'll contradict me. So like a block kept on rough surface, external force acts, how still no friction will act? Because of this condition, you must have this much of background. So don't take it very simple way that more, especially the SEO objective, no? Every question what happens, there is some background, like a numerical should be there to analyze. Because I've seen like our students, they'll take one pencil, they read question, and they'll try to search option, back they'll check key, and they'll put tick and over. Hardly you draw any diagram for that particular question. So this shows that you're just what happened, gathered some question answer, but nowhere what you really put any effort. So shall we put here, if a block kept on rough surface and external force acts, still friction will be 0. This is one example.